We challenge the solid ground under our feet, the comforting warmth of the air, the steady line of the horizon, and even what blue truly means. Our daily existence rests on a subtle belief that Earth thrives under endless sunlight. Gazing at those iconic space photos, the celebrated blue marble hanging in the emptiness, we sense something comforting and known. Swirling white clouds drift above a lively, welcoming sea, and we tell ourselves, this is our world. We picture the ocean as transparent and bathed in light, teeming with visible life. Yet that appealing, comforting blue marble is deceptive. The reality we assume isn't the norm. It's an uncommon, brief, and delicate outlier. That striking blue hue marking our planet. Just a physical ploy. A short-lived visual trick from sunlight mingling with water particles. Like a superficial layer of gloss on a towering structure without any illumination inside. Scratch away that uppermost slice, just a sliver of the ocean's vast volume, and the blue disappears in a flash. Earth's true essence isn't hue at all. It's blackness, an oppressive, compressing, timeless void that's endured for eons. 95% of this world's habitable volume lies in endless night where sunlight feels like a legend. What makes the sea fool us this thoroughly? It boils down to light's own principles. Picture yourself on a ship's deck amid the Pacific, sun blazing directly above. The water appears pristine, nearly like flowing crystal. But water isn't crystal. It's a plunderer. Sunlight strikes the ocean's face, carrying its complete range of energies, encompassing the full rainbow: red, orange, yellow, green, blue, indigo, violet. As those light particles breach the boundary and slip into the fluid, a fierce robbery unfolds. Water particles are voracious, snatching light's power in a precise sequence, beginning with the feebler wavelengths. Red falls first. It's feeble, battling the water's thickness. By merely 5 meters down, about the span of a typical sedan, red is utterly gone, soaked up by the molecules and turned to warmth. Slice your hand open at 10 meters, and the emerging blood won't gleam red. It'll seem nearly ebony or a murky, earthy green, since no red rays remain in that realm to bounce off it. Plunging further past 20 meters, the plunder persists. Orange gets taken, followed by yellow. The sea functions as a ruthless sieve, constricting the palate, draining the spectrum's cozy tones. At 30 or 40 meters, blue stands alone as the enduring holdout. Its potent energy and compact, forceful waves let it evade the molecules, delving farther than rivals. It disperses widely, reflecting upward to the surface and your sight. That's the secret behind the ocean's blue appearance. You're witnessing the spectrum's sole escapee, the final trace of sun that the depths haven't devoured. But blue's reign ends too. As we sink onward, abandoning the lit realm, blue dims to a somber indigo dusk. The overhead sun, previously a piercing orb, blurs into a weak, pallid shimmer. We're crossing into the snail's window, that odd visual effect compressing the whole overhead sky into a shrinking ring of glow as depth increases. Now we linger at humanity's boundary. Few venture beyond here. Scuba enthusiasts, breath-hold divers, and even many naval subs stay in this slender, sun-kissed veneer of the sea. We regard it as the full extent, charting reefs, monitoring tuna schools, observing dolphins leaping through swells. We believe we've grasped the ocean's essence. But we've barely grazed it, like lunar explorers eyeing boot-scuffed regolith and declaring the cosmos mapped. Deeper, the liquid chills. Pressure mounts, squeezing our mental barriers. Indigo bleeds to violet. Violet grays out. Right under this misleading luminous veil awaits the deep's initial enigma. Something immense, thick and teeming that for years duped Earth's cutting-edge gear. World War II skippers mistook it for the seabed, believed it firm stone, yet it was no stone. It was flesh. At 200 meters, surface blue has ebbed to a profound, wistful gloaming. In this shadowy fringe between day and obscurity, we meet a puzzle that once stumped the globe's mightiest force. It all started in the early 1940s, with the world engulfed in conflict. The seas had become a theater of conflict. U.S. Navy destroyers cruised the Pacific searching for hostile subs. Crews relied on an emerging tool known as sonar, emitting sound waves into the abyss and detecting their return echoes. The concept was straightforward. A rebound signal indicated either a sub or the seabed. Yet, something inexplicable started appearing on their screens. In the daytime, readings depicted a firm bottom around 300 to 500 meters below. The pulses struck a compact barrier, yielding a robust, distinct reflection that suggested modest depths. But as dusk fell, the bizarre unfolded. This apparent seafloor would shift. It ascended toward the upper layers, breaking free from the profound depths. It sometimes surged right up to the shallows. Come morning's light, it plunged back into the void, resuming its prior level. It seemed like the Earth's shell was respiring, as if the globe itself pulsed with breath in a daily cycle. For years, this enigma, dubbed the Phantom Bottom, stayed under wraps as a military riddle. Maps got revised. Skippers were baffled. What could cause ocean depths to fluctuate by hundreds of meters nightly? The eventual revelation upended our understanding of marine realms. Those sonar returns weren't from stone, sediment, or silt. They stemmed from swim bladders. The Navy had uncovered the deep scattering layer. They'd tripped over a vast animated blanket of countless small fish, shrimp, jellyfish, and squid. Clustered so tightly, they created a fleshy shield that deflected acoustics. Far beyond a mere fish shoal, this was the daily vertical migration, the planet's grandest animal trek. Dismiss the wildebeest traversing the Serengeti. Ignore the caribou roaming the tundra. By sheer mass, nothing rivals it. Night after night, trillions of tons of organisms ascend from obscurity to graze near the top, and dawn after dawn, they withdraw into obscurity. At the forefront is a modest champion, the lanternfish. Cradle one in your palm, and it appears far from ferocious, petite, seldom exceeding finger length. Yet the lanternfish reign supreme in the depths. Their abundance is staggering. Experts reckon they make up 65% of all abyssal fish mass. Tally every ocean fish by weight, and over half would be lanternfish alone. Days find them lingering in the dusky haze, concealed from surface hunters, yet not so far down as to drain their reserves. A poised limbo, poised for the cue. That cue arrives with sunset, as the sun vanishes. The surge commences. Lanternfish, joined by swarms of copepods, krill, and siphonophores, launch their climb. They're pursuing surface plankton, but it's also a perilous chase, a global-scale evasion from peril. Linger too long at dawn, and daylight hunters, tuna, dolphins, seabirds, would decimate them. Born of shadows, sunlight spells doom. Thus, they forage swiftly in nocturnal veil, and flee before dawn's glow unmasks them. Picture yourself in our submersible now poised at 300 meters. As this spectacle ignites, it resembles an inverted snowstorm. Myriad glowing specks streaming upward by the viewport. The sea teems with vitality, a hushed, frenzied biological commute. You're witnessing Earth's vital rhythm in motion. These minuscule beings consume surface carbon-laden fare, then ferry it downward, sequestering it in the depths through waste. They sustain the ocean's respiration. They underpin climatic equilibrium. This evening, we forego, trailing them to the banquet. We navigate onward, piloting the sub against the current. Plunging through this biotic haze, sonar signals weaken. The throng disperses. We're abandoning the illusory base. The surrounding water transforms once more. Indigo yields to an oppressive, choking purple. Cold intensifies sharply. Now we enter the genuine, abyssal realm. The deep, scattering layer conceals itself in daylight obscurity. But the beings ahead dwell in perpetual night. They don't journey upward. They shun the shallows. They endure. The mesopelagic zone, the true twilight realm. Here, survival dynamics shift. Where illumination dwindles to nil, the prime asset isn't fangs or agility. It's vision piercing the unseen. As we glide beyond 200 meters, the bustling frenzy of the false seafloor lies behind us, dissolving into the shadows. We're descending into a realm of hushed peril. The mesopelagic zone, often called the twilight zone. The water takes on a constant somber hue here. Peer through the porthole, and it could seem barren. A risky illusion. It's far from vacant. Something's observing you. In this depth, the fundamentals of endurance transform dramatically. Prey is rare, and the obscurity offers scant cover. Yet the true hallmark of this stratum isn't the chill or the crush of depth. It's an all-consuming fixation on vision. Below, sunlight ceases to warm. It's merely a dim, waning echo from the surface realm. The rays that trickle down this far are extraordinarily feeble, millions of times fainter than on land. Here, one lone photon of light holds worth beyond jewels. Snare that particle, and if your vision can detect that minuscule burst, a feast awaits. Overlook it, and famine looms, or worse, you end up as dinner. This Darwinian scarcity has ignited a fierce contest in visual prowess. Twilight Zone dwellers have twisted their anatomy to craft Earth's most acute sighting tools. Certain species sport eyes dominating half their craniums. Others boast reflective backings to their retinas, an amplified tapetum lucidum granting photons another shot at detection. One denizen pushes this vigilance to absurd extremes. A fish, resembling a delirious inventor's contraption. It glides soundlessly through the murk, suspended like an abstract artwork. Macropinna microstoma, the barrel-eye fish. At a casual look, it defies belief. Its visage features a petite pursed mouth with twin shadowy pits just overhead. For ages, ocean experts mistook those pits for eyes. They mimic eyes in position and placement. Wrong. They're scent detectors, basically nares attuned to the water's chemical traces. The actual eyes demand a closer inspection. Venture within the fish itself. The upper skull forms a see-through liquid-laden dome, a natural viewport as pristine as premium crystal. Suspended in that bath, shielded by bone, bob two luminous emerald orbs. These are the eyes, cylindrical, barrel-like, inspiring the title. They operate akin to potent zoom optics, and at this moment, as the creature lingers in the void, those verdant cylinders aim skyward, Picture existing perpetually gazing through your cranium's crown. This fish devotes its days peering upward, probing the pale ashen glow seeping from above, hunting for outlines poised for the form of a jelly, prawn, or siphonophore to eclipse the rays. In the twilight depths, a shadow spells exposure, the sole giveaway of quarry. Long ago, experts deemed the barely plagued by a rigid posture, eternally upward gazing. It appeared a deadly handicap. How to seize what's ahead when your sight fixates on the overhead. In 2009, scientists from the Monterey Bay Aquarium Research Institute secured crisp video of a living example. They marveled as it detected food. The emerald cylinders within the lucid vault didn't merely gaze, they pivoted. Tilting from level to upright, the fish's orbs swung ahead, zeroing in on the objective with mechanical exactness. That glassy vault serves dual purpose, not only a pain, but a barrier. The barrel-eye frequently pilfers bites from siphonophore tendrils laced with venom. The dome safeguards its fragile, ultra-attuned eyes from stings that could impair or erase sight amid these deep-sea thefts. The barrel-eye isn't unique in its odd architecture. Nearby floats the gigantura, the telescope fish. It forsakes the clear dome for a more eerie tactic. Its eyes emerge as stalk-like tubes jutting from the skull, evoking twin field glasses. Typical fish position eyes laterally for broad vigilance against threats. The telescope fish ignores the flanks. Its gaze converges ahead, merging sight lines for stereoscopic clarity. Binocular sight, range estimation, amid total dark. This lets the fish calibrate prey proximity with pinpoint calculation prior to lunging. Such beings embody the twilight zone's formidable demands. Beyond hydrostatic force, its evolutionary rigor. Adaptation has mercilessly culled the sightless. A chilling irony arises, with hunters forging zoom optics, emerald tints, and swiveling lenses to pierce shadows amid the subtle overhead glow. As prey in this realm, how do you endure? When casting a shadow spells instant doom, ducking behind a boulder won't save you. There are none to be found. Burrowing into sediment is out of the question, too, with the seabed lying kilometers beneath. You're adrift in vast exposed waters. To evade those vigilant predatory gazes, you must achieve the seemingly unattainable. Vanish entirely. Turn into a specter. At depths of 400 to 600 meters amid this realm of muted grays and relentless suspicion, existence hinges on cracking one harsh optical riddle. How does a tangible form conceal itself in a domain devoid of shelter? In the pelagic void, there's no rubble for cover, no reefs to merge with, and the ocean floor remains far below. Should a hunter glide underneath and glance upward, your form inevitably obstructs the dim surface glow leaking downward. You transform into a stark ebony silhouette against the hazy backdrop, ripe for ambush. Mere blending won't suffice down here. You need to reshape how photons engage with your very substance, obliterate your presence altogether. The premier, most refined tactic, cease to be at all. Gliding by our viewport comes a being that showcases how life conquers photonics, the cystosoma, a hyper-eyed amphipod, kin to those minuscule beach hoppers you spot on shorelines. Yet in these depths, it swells to the span of a person's palm. Even swimming alongside, you might overlook it completely. The cystosoma is virtually see-through. Its dermis, musculature, and exoskeleton gleam like crystal. Natural selection has polished away tiny surface irregularities, to curb photon deflection, aligning the creature's light-bending properties precisely with the surrounding brine. Rays glide through unimpeded, no rebounds, making the organism all but undetectable. Full clarity defies life's limits, though, due to a pair of structures that demand opacity: the eyes and digestive tract. Vision demands light capture by the retina, while the gut harbors dark, unprocessed meals forming a conspicuous patch. The cystosoma counters this via a clever angular ploy. It navigates eternally upright in the water layers, perpendicular to the flow. Such alignment shrinks its profile from underneath, slimming the gut's shadow to a slender thread, nearly impossible to discern. An entity, teetering on oblivion's brink, forever aligning to stay ethereal. Such clarity suits only spineless forms. Vertebrates like fish, burdened by sturdy skeletons and blood teeming with hemoglobin, can't go translucent. Instead, they opt for deflection. Behold the hatchet fish, a wonder of extreme flatness. Its frame is razor-edged, compressed sideways akin to a gleaming disc or the edge of a butcher's knife. Its sides gleam with stacked guanine crystals, the very material behind scale iridescence, reconfigured here as premium organic reflectors. In the twilight zone's scattered omnidirectional glow, these surfaces bounce back the encircling sea. A threat eyeing the hatchet fish sideways doesn't spot a quarry. It beholds an echo of the abyssal murk beyond. The fish merges into its surroundings, a sliver of obscurity lost in the dark. But reflectors carry a critical weakness. They camouflage laterally yet project a shadow downward. To banish that lethal dark contour against the overhead gleam, the hatchet fish deploys nature's pinnacle of bio-optics: counter-illumination. Along its ventral edge stretches a row of photophores, living light emitters crafting a gentle azure verdant radiance. These aren't haphazard. The fish meticulously calibrates their output to echo the precise luminance of the surface rays penetrating below. By generating its glow, it backfills the void it would cast, swapping out blocked illumination with its homemade equivalent. From a lurker's upward view, the outline dissolves, a responsive veil of concealment, adaptive patterning that shifts on the fly. Should a surface cloud veil the sun, muting the light 500 meters below, the hatchet fish tones down its ventral shine accordingly, a delicate balance of precision. This illusion demands a heavy toll. Bioluminescence guzzles power, sustaining a frame forever tweaking its photon yield, forever propelling and scanning, burns calories and air. And as we plunge beyond 600 meters, those essentials dwindle. The surrounding brine shifts, a stratum where the world below feels starved for breath. Here, organisms don't merely evade hunters, they conceal themselves from asphyxiation. Beyond the 600-meter depth, the intense scramble of the light-dependent chase gradually diminishes, yielding to a profound, sluggish tranquility, a segment of the sea that serves as an organic divide, an eerie, abandoned place where the core essence sustaining life has almost entirely vanished. This is the oxygen minimum zone, or OMZ. Microbes consuming the descending marine snow from above have depleted the water so thoroughly that nearly every bit of dissolved oxygen is gone, forming a choking band that encircles the world's seas. Fierce hunters, such as tuna, mako sharks, or swordfish, can't venture into this domain. Venturing here would cause their muscles to give out, leading them to drown amid the water layers. Yet nature detests emptiness, and amid this low-oxygen desolation, Organisms have adapted by essentially stretching out time. Hovering in this airless expanse, there's a being whose title summons images of eerie dread. Vampiroteuthis infernalis, meaning the vampire squid from hell. When explorers dragged it to the surface in the early 1900s, its look sent shivers through scientists. It features a mantle of deep crimson-red tissue linking its 8 tentacles, resembling a vampire donning a flowing cape. Its eyes are massive, pale blue spheres that gaze with an icy shrewdness. Along the inner sides of its tentacles run soft projections known as cirri, resembling lines of sharp fangs. Given its moniker and build, one might imagine a bloodthirsty stalker prowling the shadows, ripping into fresh victims. In truth, it's a striking twist on those assumptions. The vampire squid isn't a pursuer. It's a mild, solitary scavenger of refuse. In the OMZ's oxygen-poor setting, hunting demands excessive effort, an extravagance this species can't indulge. Rather, it has developed into a consumer of detritus. Those webbed tentacles aren't for throttling. It extends a pair of slender, retractable threads, delicate feelers that dangle through the water like baited hooks. Covered in adhesive slime, these threads snag marine snow, the plummeting remnants of perished plankton, waste matter, and tiny crustacean casings sinking from higher up. The vampire squid merely drifts silently in the gloom, allowing the sea's discarded bits to cling to its lines before pulling them back to dislodge and devour the muck. A being that ekes out existence on the leftovers from the illuminated realms above, embracing a path of quiet persistence. To persist where others would perish from lack of air, the vampire squid has transformed its inner biology. While people and most fish rely on iron-rich hemoglobin for oxygen transport, which lends blood its scarlet hue, the vampire squid employs hemocyanin, a copper-laden molecule that renders its blood azure. This hemocyanin excels at latching onto oxygen in chilly, sparse oxygen conditions, enabling the squid to glean the faintest hints of the gas from the surrounding fluid. Paired with one of the slowest metabolisms among cephalopods, it lingers in a kind of dormant stasis. Idling with minimal energy use, the supreme adapter in a territory no vigorous hunter can claim. Still, even within the asphyxiating layer, security remains elusive. Should an uncommon foe dart down momentarily for an assault, the vampire squid executes a peculiar yet potent defense. It folds its webbed tentacles fully over its body, inverting itself entirely. This _1_ stance reveals the inner jury of its mantle, rendering it prickly and distasteful. If that doesn't deter, it skips the dark ink release, pointless in pitch black. Instead, it spews a burst of shimmering bioluminescent slime packed with myriad sparkling blue spheres. This stunning light show disorients the threat, who snaps at illusory glows as the vampire squid stealthily melts back into the void. As we leave this crimson-shrouded perseverer, the surroundings shift anew. Oxygen concentrations begin to climb, gradually drawing from profound polar flows. But a fresh, unyielding adversary emerges near the 1,000-meter line. The immense burden of the water overhead asserts itself as an oppressive force. At 1,000 meters, any lingering dimness from the twilight layer vanishes utterly, plunging us into unrelenting total obscurity. Yet darkness isn't the sole power at work. As we plunge further, the overlaying ocean's mass evolves from an abstract idea into an overwhelming compressive rule. a domain where pressure surpasses 100 atmospheres. Up top, we experience just one atmosphere, a subtle press of atmosphere we scarcely sense. Down here, each 10 meters adds another atmosphere of force. Upon arriving in the abyssal plains, the squeeze will mimic an enormous African elephant poised atop a tiny postage stamp, and that stamp resting on your fingertip. For people, or any creature that breathes air, this setting proves deadly in an instant. Step out of the submersible at this moment, and the air inside your lungs, nasal passages, and inner ears would compress into a solid mass. Your rib cage would collapse inward, bones fracturing from the overwhelming force. Yet the deep sea's brutality extends well past mere skeletal destruction. It assaults the fundamental elements of existence at the cellular scale. Biology depends on precise forms at the molecular level. Proteins, those elaborate engines driving muscle movement, food breakdown, and neural impulses, require exact three-dimensional folds to operate properly. In typical surroundings, water molecules provide subtle support for these forms. But in intense, hydrostatic conditions, water gets driven into the minute gaps inside proteins, functioning like a prying tool. The pressure compacts these proteins until they unwind, a phenomenon known as denaturation. In essence, the abyss attempts to quote to you without any warmth. It compels your enzymes to distort and cease functioning, bringing the inner workings of cells to a standstill. Cell membranes, meant to stay flexible and lipid-rich for nutrient transport, get squeezed so tightly they harden like chilled butter. To endure this relentless grip, organisms in the deep have forsaken the frameworks typical of shallow water species. The initial sacrifice is any trace of air. Shallow-dwelling fish usually have a swim bladder, that gas-filled pouch aiding in buoyancy control. Here, though, such a bladder becomes an explosion risk, primed to burst inward. As a result, deep-sea dwellers have purged all air voids from their bodies. They've swapped gases for liquids and jelly-like materials matching the density of the ambient seawater. Because fluids resist compression almost entirely, the pressure flows around them instead of clashing against. That's why so many abyssal residents, from the blobfish to deep-sea jellyfish, appear limp, soggy, and formless to us. They're far from flawed in design. They're crafted from water to thrive amid water. Mere structural tweaks can't fully protect the biochemistry within cells. To shield proteins from collapse, deep-sea species have developed a molecular barrier. They flood their cells with a compound named trimethylamine N-oxide, or TMAO. Imagine TMAO as a tiny framework or brace. It latches onto water molecules, blocking their intrusion into proteins and maintaining those vital configurations despite the external crush. An intriguing everyday consequence of this trait that you probably encountered. TMAO is the substance responsible for the pungent odor of decaying fish. The deeper a creature dwells, the greater its buildup of TMAO in tissues to counter the pressure. The abyss's beasts aren't merely frightful in appearance. They're biochemically enhanced, infused with the ocean's briny aroma. This, yielding to physical laws, the foregoing of rigid skeletons, the elimination of gases, and the infusion of protective agents, gives the deep its distinctive look. The life forms down here resemble specters, supple, meandering, frequently gaunt, shedding all excess weight to preserve energy in the pressurized emptiness known as the bathypelagic zone, or the midnight zone. Here, pressures soar to enormous levels, temperatures hover just above freezing, and blackness reigns supreme. Peer through the viewport. And you'll notice the emptiness isn't barren. It's tinged with a hue that defies expectation in this realm. At 1,000 meters, the formal boundary of the bathypelagic zone, evocatively called the Midnight Zone, switch off our submersible's cabin lights, and the outer gloom turns pitch black, an oppressive murk, like spilled ink, where eyes could stare for centuries without catching one ray of sunlight. The sun isn't merely far off. It's a forgotten legend, utterly snuffed out by the thick column of water overhead. One might assume that in lightless depths, coloration serves no purpose. Why decorate in the dead of night after all? But activate our outer spotlights and the scene shifts dramatically. The void bursts into shades of crimson. Floating by the sturdy quartz window are beings in vivid, deep reds. Deep-sea shrimp with fire-truck-hued exoskeletons. Jellyfish such as the atolla, draped in flowing scarlet hems. Worms resembling glowing ruby threads. It feels like an evolutionary error. Up in the sunlit world, vivid red stands out sharply. A warning marker, like a ladybug, poison dart frog, or traffic stop sign. It demands attention, so why would stealth-seeking creatures in the shadows adorn themselves in the boldest shade imaginable? The explanation ties back to the blue light dynamics we explored earlier at the surface. Color doesn't belong intrinsically to an object. It's merely what happens when light reflects off it and reaches your retina. An apple looks red solely because it soaks up all the rainbow's hues except for red, bouncing that particular wavelength toward your gaze. Yet for any surface to send back red illumination, there needs to be some red light available in the surroundings to start with. Keep that in mind from our earlier discussion on light theft. In water, the longer red wavelengths get swallowed up right away, vanishing just a short distance below the surface. Here in the Midnight Zone, red light is entirely absent. The sole natural glow originates from bioluminescence. The glow generated by living creatures, and that radiance is mostly in the blue or green spectrum. Those shorter wavelengths penetrate farthest through the water, which is where the genius of camouflage truly shines. Imagine a predator sweeping for a meal, casting its organic blue beam over a vivid red shrimp. The crimson exterior devours that blue light entirely, sending zero reflection outward. To the hunter's vision, the shrimp doesn't register as red or even neutral gray. It's simply an empty space. It shows up as utter blackness, seamlessly fusing with the ambient water. Down in the profound depths, sporting a vivid red hue is like donning an invisibility mantle, a form of concealment that doesn't mimic patterns in the backdrop, but instead manipulates optical principles to obliterate one's outline. Still, in evolution's endless contest, no safeguard holds up forever. As prey conceals itself within the red range, one hunter has shattered the established limits. Silently floating through the murk comes the stoplight loose-jaw dragonfish, a grotesque marvel of structure, featuring a mouth that gapes to 100 degrees and fangs resembling shards of glass, but its real arsenal hides beneath the eye. Nearly all deep-sea dwellers generate blue luminescence. The dragonfish stands apart, equipped with an uncommon organ that releases red bioluminescence. It projects a long-wave red ray into the shadows, a hue undetectable to virtually every other inhabitant of the depths. Red shrimp and jellyfish remain oblivious to this glow, staying unresponsive as they assume their invisibility persists. The dragonfish, on the other hand, detects it clearly, thanks to a specialized pigment in its retina, probably gained from ingesting chlorophyll-like bacteria, enabling red light sensitivity. This grants the dragonfish an exclusive, coded view of the world. Picture a marksman with infrared sights amid foes, stumbling in total blindness. It glides through the obscurity, directing its unseen red searchlight at potential victims, pinpointing the dark forms of red shrimp and lunging before the quarry realizes it's been exposed. That's the essence of the Midnight Zone. A quiet battleground governed by physical laws where light wavelengths turn into arms and vanishing boils down to choosing the right spectrum. Spotting dinner poses just the initial challenge, though. The next hurdle is securing it in a realm so starved of energy that pursuit becomes a luxury you can't indulge. Venturing further down, red-based hiding tactics yield to more shadowy tactics. From the overwhelming pitch, darkness emerges a lone glimmer. Beyond the 1,500 meters threshold in the Midnight Zone, the intense pursuit game we observed up top starts to dissolve. Such vigorous foraging demands fuel, and this habitat offers none to spare. Rapid swimming consumes calories. Pursuing targets drains them further. In an existence where sustenance might show up only monthly, expending resources without assured payoff spells doom. The approach shifts. We're abandoning the pursuers for the realm of the steadfast waiter. A solitary gleam lingers in the emptiness, swaying softly with the flow like a firefly trapped in a vessel of ink. Dim and radiant with a subtle, mesmerizing blue-white flicker. In this photon-scarce domain, such a beacon proves magnetic. It hints at scarcity fulfilled. To a drifting crustacean or minnow, it resembles drifting marine detritus or maybe a tiny luminous larva. An easy snack. Urged by basic drives, the quarry approaches the shine. It draws near. It probes, then the shadow trailing the lure ruptures. In an instant, quicker than we can perceive, enormous jaws swallow the surrounding water, the lure and the meal alike. The snare clamps down. Enter Melanocytus johnsoni, the humpback anglerfish, the deep's emblematic terror, embodying our primal dread of the sea. Its form is a rounded ebony orb built not for velocity but for drifting, a jaws paired with a gut, basically. Yet the pinnacle of its design isn't the dentition but the rod protruding from its brow. Known as the Elysium, this extension ends in the esca, the luminous tip. What renders this beast profoundly intriguing is a peculiar biological fact. The anglerfish doesn't generate its own glow. Slice open that shining orb with a blade, and you discover no power source or wiring, just a bustling community of organisms. That bulb is essentially a hollow chamber, home to countless bioluminescent bacteria, probably from the Vibrio genus. It's one of Earth's most exquisite cases of symbiosis. Their partnership is purely pragmatic. The anglerfish offers the microbes a protected habitat and a steady flow of nutrients straight from its bloodstream. In exchange, the bacteria deliver the glow, their lifelong residents, settling their dues in bursts of light. Even more astonishing is the science behind that illumination. Within every one of those minuscule bacterial cells, a chemical process unfolds that's far superior to our finest electric lights. The bacteria contain a compound known as luciferin, so called because of Lucifer, the bearer of light. When luciferin combines with oxygen with help from an enzyme named luciferase, it emits energy as cool, pure light. In contrast to incandescent bulbs that squander 90% of their power as warmth, this natural glow is almost perfectly efficient. Nearly 100%. Brightness without any heat. Ideal for an icy, pitch-black realm. Yet, The real enigma lies in the bacteria's origin. Juvenile anglerfish don't emerge illuminated. They start out in total darkness. For a long time, researchers were stumped. Do the females transmit the bacteria to their young? The evidence suggests otherwise. Instead, the hatchlings must form a unique opening in their budding light organ, and then snag the precise bacterial strain from the surrounding seawater. It's an instant of colonization that sparks a lifelong alliance. After the correct microbes slip inside the bulb, the entrance seals shut, and the fish is primed for the chase. Speaking of which, the pursuit is a lesson in fluid dynamics. The anglerfish doesn't snap at food the usual way. It uses a powerful suck. Upon sensing something brush its bait, it abruptly enlarges its buccal cavity, the area inside its mouth. This generates enormous negative pressure. Seawater surges inward, pulling the unfortunate quarry right along. Once trapped inside, escape is futile. The anglerfish's teeth are see-through, razor-sharp, and angled rearward toward the gullet. Their brilliance, however, is in the joints. They're pliable. As prey ventures in, the teeth flatten to allow passage. Should it attempt to retreat, they spring upright and stiffen, forming unyielding spikes like the grate on a jail door. It's nature's version of a one-way funnel, simple to enter but impossible to exit. All these features, the microbial lantern, the suction jaws, the pivoting fangs, serve a single goal: minimal effort. The anglerfish is evolution's champion of thrift, suspending itself inert in the currents for days or even weeks, poised for one fatal error. But existence in the midnight zone throws up a far tougher obstacle than mere meals. The sea down there is immense, shadowy, and fully three-dimensional. Creatures are scattered so thinly that you could drift eternally without crossing paths with your own kind. Thus, for a female anglerfish, wandering those voids, stumbling upon a male, carries boundless importance. She can't let him slip away. No room for elaborate mating rituals. No chance of him vanishing into the gloom. To overcome this, the anglerfish has developed a breeding method so gruesome that early discoverers dismissed it as impossible. They didn't observe a pair coupling. They encountered a being that had melted away its own features in devotion. 2,000 meters. The isolation of the midnight zone feels tangible at this depth. The waters stretch endlessly, inky and barren. In such a barren void, the odds of two loners connecting are vanishingly tiny. For any species to persist, locating a partner isn't merely difficult. It's an improbable wonder. And wonders from the abyss are far too fickle to rely on. Natural selection has crafted a fix so extreme, so invasively intimate, that it upends our ideas of personal identity. Back in the 1920s, when pioneering oceanographers first studied anglerfish, dredged up in trawling nets, they spotted something odd. Every big, menacing specimen dangling a lure turned out to be female. These measured over 1/2 meter, armed with enormous maws and radiant lures. But where were the males? They combed the catches for similar but smaller versions, yet came up empty. What they did uncover were odd growths clinging to the female's undersides. These resembled diminutive, atrophied fish, typically just centimeters in length, latched firmly to the host's flesh. For decades, experts figured they were juveniles or maybe unrelated parasites leeching off the parent. They were mistaken. Those shrunken fixtures were the males themselves. A male anglerfish's existence reads like a grim script etched in genes. He enters life as a runt, dwarfed by his future partner, devoid of any lure, lacking formidable dentition. cursed with an underdeveloped gut that precludes sustained independence. He's launched with an internal timer, a finite energy stash courtesy of his yolk sac. His only mission in life, the very essence of his being, boils down to locating a female before hunger claims him. To support this frantic pursuit, nature has gifted him with a single extraordinary ability, an acute sense of smell. The male anglerfish boasts enormous olfactory structures, nostrils that dominate much of his skull. In essence, he functions as a mobile olfactory sensor. He samples the water flows, hunting for the precise pheromones emitted by a receptive female. He pursues this scent path relentlessly through the oppressive blackness, kilometer after kilometer, propelled by an unyielding instinctual drive. Upon reaching her, there's no romance, no ritual, no tender exchange. He darts directly to her side and clamps down with his jaws, and he holds on indefinitely. What follows the bite? The macabre wonder, or nightmare based on your view, unfolds right then. The male secretes a unique enzyme resembling a corrosive agent. It starts eroding the lining of his mouth and her abdominal area. The flesh softens, seeps, and ultimately bonds. This isn't mere attachment. It's a dissolution of corporeal barriers. The merging extends beyond the surface. Over time, his circulatory system interconnects with hers. Her circulation now sustains his form. His metabolic byproducts enter her body for processing. They transform into one unified entity sharing two forms. With this link secured, the male experiences a profound and eerie transformation. Freed from the need to forage, his vision organs degenerate and detach. His appendages weaken. His vital organs, beyond the bare minimum, break down. He dwindles to essentially a functional set of gonads nourished by her bloodstream, ready to deliver gametes on demand when she prepares to reproduce. This is sexual parasitism. It addresses the challenges of the depths. Given how rare encounters are, this approach ensures that once a partner is secured, separation is impossible. Till death do us part isn't merely a promise in these realms. It's a biological reality. A female anglerfish bears her companion eternally, a convenient reservoir of reproductive cells. Certain specimens have been discovered, bearing as many as 8 males attached, their existences subsumed into hers. This phenomenon sparked a profound biological enigma that stumped researchers for years. How does the female's defenses fail to assault the intruder? In nearly every species, attaching unrelated tissue triggers an aggressive response from the immune apparatus, treating it as a threat and expelling it. That's the reason human transplants demand immunosuppressive medications. But the female anglerfish welcomes this outsider, sustains it, and incorporates it seamlessly. Studies from 2020 uncovered the secret. These creatures have essentially excised the immune components responsible for distinguishing own from foreign. They've relinquished key protective elements, including MHC-class genes and T-cell receptors, to enable such integration. They've rendered themselves susceptible to illness purely to safeguard the lineage's continuation. A daring evolutionary wager. The profound closeness of the depths. Repulsive, indeed, the erasure of individuality, the melting of features, the demotion of a creature to an accessory. Yet it's also the pinnacle of devotion. In the frigid, compressive void, isolation spells doom. United, regardless of the price, means endurance. As the anglerfish overcomes isolation through this bonding, other inhabitants tackle starvation in isolation. What if you're solitary and the sole potential meal passing nearby dwarfs you? Merging isn't an option. You must devour it whole. Beyond the 2,500-meter threshold, pressures reach 250 atmospheres, sufficient to crumple an armored vehicle like an empty beverage container. Yet here, the true peril isn't the ocean's mass. It's the void it creates, far into the bathypelagic layer, a realm so distant from the fertile upper layers that it resembles a barren expanse devoid of life. In this immense, resource-scarce expanse, sustenance may appear weekly, monthly, or even annually. Under these harsh conditions, a fundamental principle governs every hunter's form. The desperate take what's available. As a predator suspended in obscurity, if another organism, a cephalopod, a finned creature, a crustacean, crosses your path, you can't pause to assess its suitability. You can't ponder if it'll fit your jaws. You can't fret over digestive capacity. Devour it immediately. Size and form be damned, since the next opportunity might never arrive. This relentless selective force has fashioned Earth's most mismatched beast, the pelican eel, also known as the gulper eel, or pelagic. Spot it gliding serenely with jaws shut in the gloom, and it resembles a dark streamer, predominantly tail, an elongated, slim, lash-like extension following an unassuming cranium. It appears delicate. It seems emaciated. It has minuscule visual organs, minimal stabilizing fins, and scant musculature. It appears as if a mere swirl of ocean current might shatter this being into fragments. Yet this apparent delicacy is a deliberate evolutionary compromise. The gulper eel has forsaken speed, power, eyesight, and protective covering, channeling all its adaptive resources into one key feature: capacity. Upon sensing potential food, the gulper eel shifts in a manner straight out of a grotesque sci-fi nightmare. Unlike the fixed connection in human or other familiar jaws, its mouth is held in place by flexible, stretchy bands that permit wide, unrestrained movement. As the eel gapes open, the jaw unfurls dramatically. It flares out and drops low, forming a gaping, nightmarish maw that's frequently broader than the creature's own full length. Picture an umbrella bursting open amid a fierce gale. That's the expression on the gulper eel's countenance. The throat's skin features distinctive folds and elasticity, built to inflate like a stratospheric balloon. This setup lets the gulper eel gulp down an enormous swath of water, along with whatever's inside it. Rather than chomping down, it engulfs the area where prey resides. It glides above them, functioning as an animated snare, with the quarry ensnared within that vast buccal void. The eel expels the surplus water via its gills and gulps the prize whole. Thanks to a stomach as pliable as its jaws and the absence of ribs to limit growth, it can devour creatures bigger than its own frame. Envision a python devouring a deer, but unfolding in mere moments, floating weightless in the depths. Such a capability means the gulper can go after any target it encounters. It essentially erases the notion of something being too large for a meal from its instincts. But how does a sluggish, feeble swimmer snag prey to begin with? It can't pursue a darting squid. The secret hides right at the extremity of that extended lash-like tail. Examine the tail's tip, and you'll spot a small pink photophore that emits a glow in the blackness. Experts suspect the eel employs this rosy illumination as an intricate bait. In the total void, the eel probably holds its tail close to its head, swaying the luminous end softly. To an inquisitive shrimp or a hunter seeking an easy bite, that pink gleam mimics vulnerable food. They approach, only to discover far too late that the shadow beyond the glow isn't mere empty sea. It's a gullet poised to balloon outward. The gulper eel stands as a masterpiece of simplicity, a daring biological wager declaring, quote, for the perfect symbol of survival through scarcity. Not every deep-sea dweller confronts the gloom in solitude, while the gulper eel and anglerfish prowl alone, banking on cunning and endurance. Another type of organism thrives below by embracing a contrasting approach. These don't stalk solo. They pursue as a unified group. Nearing the 3,000-meter depth, our beams illuminate what seems like a snarled web of netting spanning almost 40 meters across the murk. It's no snare, it's one vast organism formed from countless tiny components. 3,000 meters. The isolation of the gulper eel and the solitary watch of the anglerfish have sketched the abyss as a domain of remoteness. We picture the depths as a world of recluses, each life form an isolated fortress battling independently. Our lights pierce the unending dark and reveal a form that upends this view. Initially, it seems like an error. Spanning the porthole's sightline, a slender, pale strand. It resembles knotted fishing twine, or maybe a strand of slime reaching infinitely into shadow. The submersible tracks it. It stretches 10 meters, 20 meters, 40 meters, surpassing a blue whale's span, outlasting the vehicle too. It commands the water layer like a hushed, hovering thoroughfare. No litter, but a gigantic siphonophore Pruvotia. And here's the element that shatters conventional thought. What you see isn't one beast. It's an urban sprawl. The siphonophore upends our basic understanding of individuality. On the surface, an animal is a singular, bounded entity. You possess a heart-own gut, limbs all integrated into oneself. The siphonophore follows another principle, a colonial superorganism. That 40-meter cord consists of thousands of minuscule bodies known as zooids. These zooids share identical genes. They're duplicates from the founding embryo, yet they've evolved into wildly diverse forms for dedicated roles. They've specialized to such an extent that independence is impossible. Leading the formation are the nectophores, the navigators. They resemble throbbing, see-through bells. Their sole purpose, to propel water, hauling the enormous assembly through the sea. No feeding mouths for them. They can't nourish themselves. They're pure propulsion machines. Following are the gastrozoids, the digestive units. They boast mouths, yet can't propel forward. These specialized units handle the breakdown of captured prey into liquid form, extracting vital nutrients before channeling them via a communal stalk to nourish the entire colony. Protecting this fragile assembly are the dactylocids, the defensive warriors. These are elongated, slender appendages, equipped with countless venomous stinging cells known as nematocysts. They create a deadly veil dangling into the depths, ensnaring any unwitting shrimp or fish that ventures too close to the group. Picture your fingers as independent beings, your digestive system as yet another entity, and your limbs as a distinct organism, all linked together, circulating a unified blood supply and coordinating flawlessly. That's the essence of a siphonophore, a collective biological intelligence that blurs the boundaries between individual and multitude. Down in the still waters of the Midnight Zone, this approach proves ruthlessly successful. One such siphonophore can unfurl a tentacle web spanning hundreds of square meters. No active pursuit required. It merely claims territory. In doing so, it converts an expansive expanse of barren seawater into a hazardous trap, Upon contact with prey, the obscurity erupts into brilliance. The majority of siphonophores possess bioluminescence. When provoked, they don't merely illuminate. They throb with energy. Cascades of azure luminescence cascade along the colony's form, reminiscent of toppling dominoes. Certain types emit vivid crimson glows at their tentacle ends to mimic lures, much like the anglerfish, whereas others disperse shimmering particles into the currents to divert threats. It's a wordless pyrotechnic spectacle in an empty auditorium. Encountering a siphonophore in the abyss serves as a potent lesson that life doesn't always adhere to the vertebrate paradigm. We're fixated on centralized features like skulls, intellects, and command centers. Yet the sea frequently favors dispersion. It thrives on interconnected webs. As these quiet, drifting metropolises command the visible realm of the depths, another dimension of the ocean emerges, not through sight, but through sound. The deep sea is pitch black, granted, but far from hushed. We often envision the profound depths as a soundless tomb. Absent the surf's roar, avian cries overhead, or vessel motors droning, we picture the void as a realm of utter, oppressive silence, a false notion stemming from our sensory shortcomings. Silence the submersible's engines and truly attune yourself with proper equipment, and you discover the sea brims with noise. It's a symphony of rumbles, snaps, shrills, and moans. At a particular depth, typically around 1,000 meters varying by latitude, the waters evolve into a worldwide acoustic conduit that challenges our aerial notions of sound propagation. Enter the SOFAR channel, or sound fixing and ranging. Sound velocity in seawater hinges on the interplay of temperature and pressure. At shallow levels, warmth accelerates it. Deeper down, cooling decelerates the waves. Further still, immense pressure dominates, densifying the medium and boosting speed once more. Nestled amid these rapid zones lies an optimal layer, a corridor of slowest sound travel. Once a sound enters here, it's confined. Attempting ascent toward the sunlit warmth refracts it downward. A downward curve toward the pressurized abyss bounces it upward. Thus, the acoustic signal narrows into a focused stream, ricocheting like photons in an optical fiber. Within this pathway, bass tones persist beyond short distances. They propagate vast expanses. They span full ocean basins. A blue whale's song from Ireland's shores might reach another off the Caribbean, thousands of kilometers distant. It's the web of cetaceans, a primordial global messaging system, predating our earliest wires by eons. Occasionally, the SOFAR channel transmits calls alien to whales. That summer of 1997, NOAA hydrophones captured a transmission that stunned experts. It emanated from an isolated spot in the South Pacific, westward of South America's southern extremity. This ultra-low-frequency emission was intense and biological, climbing in pitch over roughly 1 minute, and potent enough for detection across sensors separated by over 5,000 kilometers. Dubbed the bloop, it sparked endless speculation among enthusiasts and researchers alike. Its sonic signature eerily echoed a live organism, akin to a sea creature's utterance, but the intensity defied belief, multiple times surpassing a blue whale's bellow, the planet's noisiest documented beast. Should it stem from an animal, the source would need to be colossal, a mythic behemoth eclipsing all catalogued marine giants. This ignited tales of hidden abyssal horrors or ancient relics lurking below. Reality, however, unveiled something far more awe-inspiring than mere monstrosity. Extensive studies and follow-up recordings eventually uncovered the bloop's true origin. the rumble of a colossal geological event, specifically an icequake. Enormous icebergs calving from Antarctic ice shelves, then fracturing as they encounter warmer seas, generate powerful low-frequency vibrations that closely resemble the calls of living creatures. The sea itself seems to moan beneath the burden of moving ice masses, though it fell short of summoning eldritch horrors like Cthulhu. This discovery underscored the immense powers shaping the ocean depths. Earth's geological rumblings echo across vast distances, spanning entire continents. Still, amid these recordings, one biological enigma persists in the SOFAR channel, evoking far deeper sorrow than the crash of ice. From the late 1980s onward, sonar arrays have captured a lone, persistent cry echoing through the North Pacific. It's the song of a whale, yet utterly distinct from its kin. While blue whales emit calls between 10 and 39 hertz, and fin whales hover around 20 hertz, this solitary singer reaches 52 hertz, a notably elevated pitch. That divergence has dubbed it the world's loneliest whale, due to its unusual tone. Experts theorize that fellow whales might not detect it at all, or fail to identify it as kin even if they do. It roams in isolation, tracing paths along the Pacific's length, broadcasting into the SOFAR channel season after season, only to meet silence. Its route strays from the established trails of other whale populations. Like a spectral signal in the system, this singular sonic footprint wanders the blackness, crooning a melody that our technology alone perceives amid the SOFAR channel's bustling soundscape. Our plunge continues. The melancholic whale's echoes dissolve into the background hiss as we venture beyond the sound strata, heading toward the tangible floor. Dropping to about 1,000 meters in the Gulf of Mexico, our sonar detects a broad, mirroring plain below. Through the viewport, the sight defies logic. We're submerged deep in the sea, enveloped by water on all sides. But there it looks like a sandy shore encircling a separate aquatic expanse, a lake embedded in the ocean bed, complete with a defined edge, a glistening top, and even faint ripples dancing over it. No illusion, and absolutely no inviting spot for a dip. This is a brine pool, in particular one so deadly that its 2015 discoverers christened it the Jacuzzi of Despair. A body of water nested within the sea might challenge basic physics. Yet it's a clear showcase of density principles. The liquid within isn't ordinary seawater. It's hypersaline brine, leached from primordial salt layers entombed under the sea floor from the Jurassic era, remnants of an ancient epoch when seas evaporated, abandoning enormous salt pans. This solution is 4 to 5 times as salty as the encircling ocean, rendering it extraordinarily thick and weighty. That intense heaviness prevents it from blending with the overlaying waters. Rather, it pools in seafloor hollows, creating a clear, stratified boundary. It lingers there much like oil atop vinegar, resisting integration and forming a crisp divide called the halocline. The Jacuzzi of Despair presents a mesmerizing, eerie allure. Its perimeter features a fringe of mussels, gathered like sunbathers along a coast, while the brine gleams with a rainbow sheen from the optical contrast with the surrounding sea. But this allure conceals peril. The basin brims with deadly compounds, laden with methane and hydrogen sulfide, and utterly barren of oxygen, a steaming, briny vat of venom. The true terror emerges upon inspecting the pool's floor. A necropolis. Dotting its base lie the corpses of numerous sizable crabs and amphipods. These foragers probably edged too near while hunting sustenance. Maybe they tumbled in, or the methane's odor lured them across the threshold. Once they breached that line and sank into the brine, doom was instant. The onslaught of extreme salinity triggered severe osmotic shock, probably sparking convulsions or immobility in mere moments. They drowned and perished on the spot, locked in pristine suspension within the poisonous brew. The creepiest aspect: the crabs show no decay. In typical ocean realms, a fallen crab would fall to predators or microbial breakdown in days. But the jacuzzi's lethal salinity and toxicity wipe out even bacteria, so nothing breaks down inside. It cures its casualties like preserves. Those crabs might have perished recently or a decade past. They remain flawless relics, frozen in perpetual demise, exhibited in a gallery of horrors unintended for any eyes. Even so, existence persists on the brink of oblivion. The mussel band, thriving at the rim, endures via a partnership with methane-metabolizing bacteria, harnessing the fumes rising from the depths. These mussels perch perilously along the edge, harnessing the toxin as their energy source without ever venturing into the deadly basin. It's a vivid emblem of the sea's contrasting nature, a realm where existence stretches to its breaking point, mere inches from total annihilation. Departing this submerged necropolis, with the fossilized crabs entombed in their brine-filled crypt, the terrain starts to shift. The striking formations of the continental shelf and salt domes recede into the distance. The ocean floor levels off. Jagged protrusions vanish as we descend beyond the 4,000-meter threshold into Earth's most expansive and uniform ecosystem. 4,000 meters. The abyssopelagic zone. The name stems from the Greek abyssus, denoting endless depth. For ages, mariners and initial cartographers imagined this expanse as an unending chasm. Today, we understand it has a tangible floor, though its immensity defies easy grasp. Gliding across the abyssal plains, immense level stretches of silt, spanning almost 50% of the planet's surface, our world's biggest habitat, yet explored less thoroughly than Mars's terrain. Peer through the viewport, and you'd behold a barren moon-like expanse, boundless uniformity shrouded in a dense blanket of ooze. That's the scientific label for the supple, ashen sludge formed from tiny skeletons of diatoms, radiolarians, and foraminifera, which have cascaded from above over eons. This buildup is the residue of ages past. Plunge your fingers into it, and you'd grasp relics from an era when woolly mammoths roamed, an realm dominated by oppressive quiet, unending night, and chilling cold just shy of ice. In this barren void, lacking shelters like stones and with sustenance carried by erratic flows, active pursuit wastes precious energy. To endure, you forego motion and transform into an motionless figure rooted in the yielding sediment. Among the oddest evolutionary tricks in the vertebrate world. Bathypteroic grallator, the tripod fish. From afar, it scarcely resembles a swimmer, more like discarded machinery or a tripod for filming. This species has warped the typical fish form into extreme elongation. Its pelvic fins and caudal tail fin extend into stiff bone-like spines exceeding a meter in length. Securing these in position forms a steady three-point base, propping the body clear of the seabed. Such positioning represents brilliant design. By raising itself, The tripod fish positions its head within the subtle flow layer, high enough to snag passing tiny crustaceans and zooplankton, low enough for steadiness. It orients toward the stream, converting its jaws into an effortless trap. The changes extend beyond. Its pectoral fins, normally for maneuvering, have developed into elongated fan-shaped feelers. Extended ahead, they probe the currents like a sightless person with a staff, detecting faint collisions from prey in the total gloom. When a prawn collides with these detectors, the fish seizes it swiftly. No pursuit required. It simply awaits the sea's delivery. Yet the abyssal plains pose a challenge beyond scarcity. Isolation. Density here is woefully sparse. You might perch on your supports for a decade without encountering kin. For a male tripod fish, spotting only another male after years spells the end of your lineage. Nature, ever unforgiving, counters this by erasing sex differences altogether. The tripod fish functions as a simultaneous hermaphrodite. Each specimen harbors complete male and female genitals. This sidesteps mismatched pairings. Should two cross paths in the obscurity, they pair immediately, each impregnating the other while depositing eggs, effectively doubling the yield. The strategy delves deeper. If solitude persists lifelong without companionship, a backup exists. It self-inseminates, using its sperm to spark its eggs and produce cloned offspring, safeguarding the lineage from oblivion. Alone. Immobile life crafted for an environment where motion drains resources and encounters are legends. The tripod fish stands guard over the silt, a being that tames the emptiness through utter stillness. As we traverse these perpetual flats, the deposits evolve. The weight intensifies, drawing us to a being that has yielded to the depth's forces in a wholly opposite manner. While the tripod fish erected supports to rise above the ooze, the upcoming resident has melted its skeleton to merge seamlessly with the surrounding fluid. The tripod fish's stiff, elevated legs represent a defiant stand against the seafloor's ooze, transforming the animal into a kind of underwater scaffold to resist the flow. As we glide further into the abyssal depths, observing the ingenious ways organisms endure the relentless squeeze, we now face an entity that has embraced the very opposite tactic. Rather than resisting the immense force with rigid bones and projections, this being has yielded to it utterly. You're probably more familiar with it as a joke than as a real organism, an internet phenomenon that embodies repulsiveness. Meet Cyclutes marcodus, better known as the blobfish. That infamous photo is etched in your mind. A floppy, rosy blob of goo sprawled on a plastic surface, featuring a sagging, bulbous snout, a broad, downturned mouth, and glassy eyes gazing vacantly with an air of deep, soul-crushing sorrow. Back in 2013, the Ugly Animal Preservation Society ran a public poll, and the blobfish triumphed overwhelmingly, earning the title of the planet's most hideous creature. From that point on, it's morphed into a viral meme, a stuffed plaything, and an icon for all the creepy, off-putting aspects of the ocean's hidden realms. It's time we made amends to the blobfish. The snapshot we ridicule, the visage we deride, isn't a true depiction of the animal thriving in its habitat. It's more like a snapshot of a tragedy, the aftermath of a body enduring devastating physical damage. Typical shallow water fish rely on a swim bladder, that gas-filled pouch inside them, functioning as a buoyant sac similar to a balloon. They adjust its size to ascend or descend as needed. But in the blobfish's habitat, usually from 600 to 1,200 meters down, with kin venturing even further. That kind of bladder becomes a dangerous weakness. The surrounding pressure there is about 120 times stronger than at sea level. Maintaining inflation against such intensity without implosion would demand enormous muscle power and energy reserves, which simply aren't available in those sparse conditions. Evolution led the blobfish to ditch the swim bladder altogether. In its place, the creature re-engineered its own makeup. Its form consists of a jelly-like material whose density is just a tad lighter than seawater. Basically a biological flotation device, a weightless blob of gel that drifts lazily over the bottom without strain. It boasts minimal musculature, no real bony framework, and flexible, yielding cartilage. Down there, enveloped in the ocean's compressive embrace that sculpts and supports its shape, the blobfish resembles an actual fish. It holds a defined outline, a narrowing tail, and a wide head with a somewhat sullen vibe. No stunner, to be sure, but an effective, sleek design, finely tuned to its pressurized domain. The real misfortune strikes when a scientific ship or deep-sea trawler sweeps a net along the bed. Once snared and pulled toward the surface, the blobfish undergoes a brutal, lethal pressure shift. As the net ascends, the external force plummets from 120 atmospheres to a single one. The gases embedded in its jelly expand with explosive force. Cell walls burst open. The form it depends on ambient pressure to sustain disintegrates entirely. When it finally spills onto the vessel's deck, it's essentially liquefied. A shapeless mess of mangled goo, its traits warping into that signature sagging scowl. Scoffing at the blobfish's surface-bound underscore, quote, _6_, is like exposing a person to the void of space-on spacesuit and then jeering at their gruesome demise. It's the tale of an organism ripped from its element in the icy blackness. This is a pinnacle of streamlined living, hovering idly, poised for a crab or worm to drift within reach of its jaws. It drives home that biological allure depends on context. To our eyes, it seems grotesque, but it's merely a resilient adapter we've yanked into an alien realm. Bidding farewell to the blobfish's poignant saga, we press onward past the 6,000-meter threshold, where another oddity awaits, one whose eerie form can't be chalked up to pressure changes or injury. Something lurks in the inky currents beneath, eluding simple labels. It bears no resemblance to a typical fish or cephalopod. Instead, it evokes a crude, shaky sketch from a scared kid's hand, a spindly outline in the void. Beyond 5,000 meters, we leave the realms of the maligned blobfish and the rooted tripod fish, stepping into zones that test the boundaries of life's endurance. Here, the gloom carries a thick, vigilant weight. While deep-sea revelations often stem from purposeful research voyages, the creepiest run-ins have cropped up unexpectedly. During the early 2000s, as energy firms extended their rigs into ever greater abysses for oil and gas, they deployed remotely operated vehicles, ROVs, to check their installations. These underwater machines, fitted with intense spotlights and low-res cameras, were scanning for any signs of seepage or wear. But on November 11, 2007, close to a Shell oil rig in the Gulf of Mexico, one stumbled upon a spectral figure. The video from that moment is fuzzy, tinted green, and profoundly quiet. Still, it stands as one of the most iconic deep-sea recordings ever made. As the ROV sweeps through the inky depths, it uncovers an organism that stirs an instinctive unease in our minds. It's a squid, yet utterly unlike the powerful, jet-squirting predators familiar from shallower seas. Magna Pina, known as the big-fin squid. Its torso is compact and ghostly white, crowned by enormous, undulating fins that evoke elephant ears or moth wings. The true intrigue, or terror, based on your comfort with the mysterious, resides in its limbs. Typical squids sport 8 arms plus 2 extended tentacles for capturing prey, often coiled neatly or hidden away until the lunge. Magna Pina defies convention. It boasts 10 uniform limbs, all alike, extending remarkably far into the void, perhaps 4 or even 8 meters. Slender as threads, stark white like bleached bone, these arms don't sway gently with the flow. Rather, they dangle rigidly, downward from the core, before suddenly kinking. Each one extends at a precise 90-degree bend, forming clear joints prior to plunging straight again. This angular setup is what unnerves us. We're wired for nature's arcs, coils, and smooth flows. Straight lines feel alien. An entity with such jointed limbs suspended in the gloom appears man-made. It resembles a severed marionette or a crude sketch by a scared kid. The squid lingers in the water layer, utterly still, its appendages cascading beneath like slender, pale digits forming a veil. It doesn't propel itself so much as glide through the currents, with an ethereal, disquieting poise. Our grasp of Magna Pina remains woefully limited. No living example has ever been brought to the surface. No intact carcass has been recovered. All insights derive from these fluke sightings via industrial gear. We theorize the bent stance aids in foraging, by fanning out its arms and allowing the adhesive tips on its tentacles to sweep through the water or skim the bottom. It fashions a vast detection web. In effect, it's passively fishing, poised for a tiny crustacean or zooplankton, to snag on those filament-like strands. A laid-back predator, a watchful guardian transforming its surroundings into a snare. What defines Magna Pina most is the quiet mystery enveloping it. We've never witnessed it feeding, nor mating, reproduction, growth rates, lifespan, all unknown. We've only glimpsed them, gazing at our lenses, floating in the hush, observing as our clanging, illuminated probes disrupt their domain. They serve as a stark lesson. In our modern era, the sea still yields enigmas beyond comprehension, beings that echo aliens lurking in our own depths. The big-fin squid slips away into the obscurity overhead as we press onward, nearing a crucial divide. The expansive, abyssal flats recede, giving way to sheer, rugged gullies that slice profoundly into the Earth's shell. External pressure now crushes not merely skeletons, but life's basic molecules, abandoning the abyss for the Hadal zone. The true trenches beyond 6,000 meters forsaking those broad-level abyssal expanses. The landscape beyond our view has shifted dramatically through tectonic fury. No longer a smooth seabed meadow, it's now a precipitous, serrated incline, boring into the planet's core. The Hadal zone, so called for Hades, the realm's Greek deity. These are the great chasms, the Marana, the Tonga, the Kirk, profound wounds from subduction, where plates grind one under the other. Pressures here surpass 800 atmospheres. A force so overwhelming it mimics not liquid, but an unyielding clamp. One might assume this unforgiving realm hosts no intricate organisms, a barren void where evolution falters. Yet examine footage from a submersible probe in the Izuasawara Trench, precisely at 8,336 meters, a depth verified just in 2023. What emerges challenges natural order itself. not some behemoth or reinforced behemoth engineered against the squeeze. Instead, a diminutive, pallid, tadpole-shaped form, undulating with soft, airy finesse, the Hadal snailfish, Pseudolipus. Its epidermis is see-through and jelly-like, so sheer you glimpse its innards from the side. Devoid of armor or barbs, it appears as breakable as sodden parchment. Nevertheless, this frail marvel reigns as the profoundest diving backbone on record. The snailfish's ability to thrive in such profound depths represents a triumph of biochemical ingenuity. Yet it also reveals the boundaries of survival. To endure pressures capable of demolishing a titanium submersible, this creature fills its cells with trimethylamine N-oxide, or TMAO, the very pressure antagonist molecule mentioned before. TMAO serves as a stabilizing brace, preventing proteins from folding under the strain. Down in the abyss, the principle is straightforward. The greater the depth, the higher the TMAO levels required to sustain cellular operations. But this adaptive strategy carries an inevitable limit tied to basic math. Beyond countering pressure, TMAO engages with water molecules, elevating the solute levels within the fish's body and rendering its bodily fluids increasingly saline. In the marine realm, a perpetual struggle unfolds between external seawater and internal fluids, driven by osmosis. Water instinctively moves from less salty areas to more concentrated ones. Ocean-dwelling fish must tirelessly regulate their internal balance to match the surrounding brine. As the snailfish descends further, injecting ever greater amounts of TMAO into its cells to combat escalating pressure, its fluids grow progressively saltier. Scientists have determined that around 8,400 meters, this equilibrium reaches an unyielding threshold. At precisely that depth, the TMAO concentration needed to offset the pressure would render the fish's cells isosmotic with the ocean, perfectly matched in salinity. Venturing even slightly beyond, say, a few meters lower, would demand additional TMAO, tipping the cells hyperosmotic compared to the seawater. Disaster would follow swiftly. Seawater would surge inward to equalize the salt levels, bloating and bursting the cells, or the sheer toxicity of excess TMAO would paralyze the nervous system. This biochemical barrier, etched invisibly in the depths by thermodynamic principles, stands firm. The snailfish spotted at 8,336 meters aren't merely fortunate survivors. They're teetering on the brink of biological feasibility. They're perched at the pinnacle of their evolutionary climb like mountaineers on Everest's peak, lungs burning in rarefied air, incapable of ascending another inch. Only here, it's the descent that's halted. They can't plunge a single meter more. Thus, peering into the Mariana Trench's profoundest reaches, which drop to almost 11,000 meters, reveals no fish at all. The snailfish have reached the evolutionary impasse for vertebrates. Below 8,400 meters lies a fish-free void. Yet the sea persists, with close to 3 kilometers more before touching bedrock. If something as intricate as a fish, with its brain, heart, and neural network, can't withstand the trench's chemical rigors, what could possibly endure? To persist at the planet's true nadir, organisms must shed sophistication. They must hark back to primordial simplicity. The depth meter shows 10,935 meters. Challenger deep, the Mariana Trench's uttermost low, and essentially Earth's foundational layer. Stepping onto the ooze here would mean bearing over 1,000 atmospheres from the water column overhead, akin to shouldering the weight of 50 jumbo jets. At this extreme, biology's physical constraints have eroded nearly all familiar traits of life. No snailfish dwell here. Their chemistry barred them thousands of meters higher. Absent are crabs, sharks, or squid as well. Gazing through the sturdy quartz porthole at the vast, monotonous gray silt plain, one might deem it a wasteland, presuming the icy cold, pitch blackness, and immense crush have purged all vitality. But examine the muck more intently. Dotted amid the powdery sediment, like wreckage from a sunken vessel, lie peculiar, irregular forms. Some span fist-sized, others rival grapefruits or dinner plates in girth. They resemble cast-off sponges or wadded aluminum foil dropped overboard. Not stones, living entities, xenophyophores, arguably the planet's most extraterrestrial beings. What defies understanding isn't their form but their very essence as organisms. Each lump, some up to 20 centimeters wide, constitutes a solitary cell. Let that sink in, the sheer improbability of it. In our understanding of biology, cells are minuscule, mere components, invisible without magnification, the foundational units assembling into grander structures. Your body alone harbors about 30 trillion such cells, collaborating seamlessly, but in this oppressive gloom, life deems cooperation unaffordable. Elaborate systems drain too much energy to sustain. Thus, xenophyophores stay unicellular, their amoebas ballooned to the scale of a person's head. These enormous single-celled organisms resemble fragile, oversized sacs filled with cytoplasm, housing countless nuclei that drift inside a unified external membrane. Masters of the emptiness. The term xenapiophore derives from Greek roots signifying carrier of alien elements, which precisely captures their method of endurance. Devoid of their own rigid framework, these colossal amoebas inch along the seabed sediment, gathering minuscule sand particles, jagged bits of shell, and volcanic ash. They produce a viscous natural adhesive to fuse these bits, constructing a delicate, elaborate casing, known as a test, that shields their squishy, jelly-like forms from swirling waters and hunters. True builders, they fashion their skeletons from the sea's discarded debris. Their feeding habits prove even more bizarre than their construction techniques. The ooze in the Haddle trenches isn't mere dirt. It's a repository for contaminants. Heavy metals and contaminants that infiltrate the ocean gradually settle at the depths, piling up in these chasms like grime in a drain. Far from merely enduring this poisonous environment, the xenophores appear to flourish within it. Examinations by researchers reveal that these beings harbor extraordinarily elevated amounts of lead, uranium, and mercury, concentrations that would swiftly lethal to nearly every other species. They emit natural radiation. They embody extreme toxicity, functioning as quiet filters for dangerous refuse, methodically combing the muck for microbes and organic matter, while incidentally taking in the world's venomous byproducts. Their intense poisonous nature ensures that scarcely any predators dare consume them. They linger untouched, occasionally for years on end, expanding gradually amid the quiet. Their existence carries a profound sense of humility. Xenapia represent an ancient lineage tracing back over hundreds of millions of years. They have occupied this sediment through the ascent and decline of dinosaurs, observing from 11 kilometers away. They registered the tremors from the impact that ended the Cretaceous era. They endured the glacial periods as steadfast observers of the planet, unaltered and indifferent. The ideal form for an environment where survival demands the utmost resilience. Evidence that triumph in evolution doesn't require intelligence, speed, or intricacy, just sheer durability. Yet, these glowing recluses aren't the sole mystery concealed by the planet's lowest realms. For ages, humanity assumed all terrestrial life, including the xenophorus, relied ultimately on solar energy. We held that oxygen arose solely from photosynthetic processes in plants and algae. We figured the profound sea merely utilized oxygen diffusing downward from sunlit zone. In July 2024, researchers probing the deep Pacific upended those assumptions. They uncovered something on the ocean bottom that respired, yet it lacked vitality. Throughout the history of biological inquiry, a core principle has anchored our comprehension of existence. Oxygen originates from sunlight. It's drilled into us from early education. Through solar power, plants, algae, and cyanobacteria split carbon dioxide to yield oxygen, the powerhouse behind our air. By extension, in the lightless depths, oxygen creation seemed impossible. Creatures of the void, whether vampire squid or snailfish, endure by inhaling the oxygen that trickles down from upper layers. The abyssal sea acts as a user, not a generator, a sink for metabolic activity. In July 2024, a group of experts exploring the Clarion-Clipperton Zone, an expansive Pacific region spanning from Hawaii to Mexico, proved the established knowledge flawed. They deployed submersibles to the seafloor at 4,000 meters, tracking oxygen use on the plane. Anticipating a gradual decline as seafloor microbes and deep-dwelling animals depleted the supply, they were stunned instead. Readings showed oxygen concentrations rising. Initially, the team suspected faulty gear. In scientific practice, anomalous data contradicting natural principles prompts scrutiny of the tools, not the principles themselves. They adjusted the instruments. They applied alternative techniques. They dispatched fresh probes. The findings held firm. In utter blackness, 4 kilometers under the surface, vast quantities of new oxygen emerged. The seabed itself was respiring. This shadowy oxygen didn't stem from vegetation or concealed algal clusters. Instead, it arose from the rock strewn like scattered beads across the abyssal silt. Millions of dark potato-like formations termed polytalic nodules. These geological curiosities develop over eons, accreting layers around a core, such as a shark's tooth or shell shard, drawing metals straight from the surrounding brine. They brim with manganese, nickel, copper, and cobalt. For years, we've regarded them merely as ore reserves, inert metallic clumps embedded in the sediment. A recent 2024 investigation uncovered that these formations carry an electrical charge. The distinct arrangement of various metals within each nodule generates a potential difference. In essence, they function as geological batteries. By inserting probes into one nodule's exterior, scientists recorded voltages as high as 0.95 volts. That figure may seem modest. After all, a standard battery delivers 1.5 volts. Yet these nodules aren't isolated. They cluster in vast numbers, billions strong, in constant contact through the salty, conductive ocean water. In thick concentrations, they mimic batteries, linked in series, amplifying the overall electrical output dramatically. Once the surface voltage on these stones hits about 1.5 volts, it sparks a reaction called seawater electrolysis. The current literally tears water molecules asunder, breaking H2O into hydrogen and oxygen. The oxygen then disperses into the surrounding water, forming pockets of breathable air amid otherwise lifeless expanses. This finding upends our understanding of how life began. Previously, we assumed advanced organisms on Earth emerged only after cyanobacteria flooded the air with oxygen through photosynthesis. But if the ocean floor has been quietly producing quote, ate for eons through purely geological means. Early oxygen-breathing creatures could have arisen in the depths well before sunlight played any role. The habitable zone for life turns out to be far broader than imagined. If rocks can generate oxygen in utter darkness, then the hidden oceans beneath the icy shells of Europa, Jupiter's moon, or Enceladus, Saturn's satellite, sealed under kilometers of frost, might harbor oxygenated seas teeming with intricate air-dependent life, powered solely by electrified seafloor stones. The deep sea isn't a stifling vault, it's a charged paradise. Yet this breakthrough carries a stark contradiction. The very nodules fueling this oxygen and nurturing the deep's bizarre xenophorans and spectral dwellers are precisely the minerals we're eager to extract. Loaded with essential cobalt and nickel, these polymetallic treasures are vital for crafting lithium-ion batteries in our EVs and mobile devices. We label it the shift to sustainability. To protect the skies overhead, we're gearing up to deploy enormous robotic miners to ravage the seabed, poised on the edge of environmental catastrophe, right as we learn the ocean bottom acts as a vital, pulsating organ that possibly sparked life itself. We're advancing schemes to suck it dry. We're set to dismantle this otherworldly realm before we've even charted its full extent. Such awareness casts a profound sorrow over our expedition's close. We ventured here seeking beasts. We sought the extraterrestrial, the bizarre, the alarming. Gazing at the plastic sack beside the charged stone, amid the gouges from experimental mining paths scarring the ooze, it dawns on us. The deadliest threat in the abyss isn't the immense pressure, the biting chill, or the relentless starvation. It's humanity, the journey's finale. The depth meter shows 10,928 meters, suspended mere feet from Challenger Deep's floor. The planet's most profound known crevice, a realm of such utter seclusion that fewer people have reached it than have stepped onto the lunar surface. We're distanced from the sun-drenched realm. More than a passenger jet at cruising height is from terra firma. Amid this icy, bone-crushing hush, we anticipate untouched wilds, a sanctuary free from humankind's turbulent grasp. In 2019, explorer Victor Vescovo steered his titanium submersible limiting factor to this precise location, shattering records for the deepest unaccompanied descent. Peering through the porthole, he spotted something that demolished any sense of remoteness. Half embedded in the timeless gray muck, swaying faintly in the feeble flow stirred by the propellers, lay no mythical creature or unearthly edifice, but a plastic shopping bag. Consider the staggering odds of that item's journey. Probably churned out in some Asian or North American plant. It served perhaps 20 minutes hauling foodstuffs, got tossed aside, then drifted countless kilometers, plunging through stratified waters, evading predators like sharks and whales while navigating fierce flows, only to settle at the world's literal nadir. It beat us there. This sighting embodies a chilling truth about oceanic topography, the pull of the gravity funnel. We often view the sea as an endless void, convinced that discarded trash simply disappears. But there's no true away. Shelves off continents descend to vast abyssal flats, and those flats funnel further into gouging trenches. Gravity drags it all, tattered nets, bottle tops, tiny plastic shreds, into these crustal clefts shaped like inverted V's. The trenches serve as Earth's grandest sinks. Whatever plastic settles here stays forever. Down in that icy, lightless void, ultraviolet rays can't degrade the plastics at all. That plastic bag might linger there for centuries on end, a man-made relic from humanity's legacy. The obvious debris is merely the surface layer of the problem. The true nightmare unfolds at the tiniest scales. Researchers are now examining the amphipods, those small, shrimp-like bottom feeders inhabiting the trenches. Upon cutting them open, they discovered plastic strands embedded throughout their guts. Remarkably, a recently identified species from the Mariana Trench carried such heavy loads of polyethylene terylate, PT, that scientists formally dubbed it Urethanes plasticus. Humanity has inscribed its mark right into the genetic code of the planet's most profound inhabitants. We've tainted the very lifeblood of beings that dwell forever in shadow. Faced with this grim truth, it's time to depart. We release the ballast, those iron slabs that sink into the sediment, etching our last trace, and the submersible starts its climb. The return to the surface unfolds gradually, methodically retracing the descent. Haste isn't an option, even sealed within our reinforced shell. The rise stirs the mind as intensely as the body. We monitor the depth reading ticking upward through the ages. We abandon the poisonous xenophores and shadowy oxygen nodules below. We ascend beyond the 8,400-meter biochemical barrier, where snailfish teeter at the brink of oblivion. We glide through the vast abyssal flats, forsaking the motionless tripod fish in their timeless poise. We traverse the midnight layer, waving goodbye to the ravenous gulper eel's frenzy and the anglerfish's eerie bond. Crossing the 500-meter threshold, hints of blue start to reclaim the scene. Peer through the porthole. For so long your vision has grown accustomed to an oppressive, total void. But now the water's composition undoes its earlier plunder. At first, the pitch dark eases into a profound, somber indigo, like a storm-torn evening sky. Then, as sunlight's particles once more clash with the liquid, that indigo deepens into a vibrant, majestic blue. We're emerging back into the realm of illumination. Surfacing at last, the lid unseals, unleashing a torrent of sensations. The sharp tang of brine and seaweed, the crash of surf, the fierce glare of untamed daylight. It's akin to surfacing from an intense, lingering reverie. Gazing across the shimmering, endless seascape, you grasp that the sea has forever altered in your eyes. The azure orb we cherish hides deeper truths. You see that our planet's essence isn't the bright expanse we inhabit. The authentic Earth lies in chill, gloom, and pressure. The default state here is the midnight zone's endless night. We, those surface dwellers, basking in warmth and air, are the oddities, the delicate outliers perched in the loft of an immensely shadowy domain. This leads to the core insight about our dread. What sparks theophobia in us? Why do beings like the big-fin squid or anglerfish provoke such primal unease, a sense of distortion that experts label the uncanny valley as if they're flaws in reality's fabric? Our ancestry unfolded across open grasslands amid a landscape of solid ground, foliage, and visible edges. We grasp environments with limbs and expressions. The profound sea, though, is a realm of boundless drift. No fixed orientation, no cycles of light and dark. Its denizens have evolved under forces alien to us. They've shed skeletons, ballooned jaws, merged forms. They're no fiends. Rather, they're elegant adaptations to enigmas beyond our ken. Our terror stems from their cue that we're mere guests on this world, not its stars. These depths have pulsed with life for eons predating us, and they'll endure long past our era and our refuse. The sea slumbers. Colossal forms lurk in obscurity while we skim the rooftop of their domain.